on entrepreneurship and additive manufacturing. So give me a minute. I'm going to pull all of the participants up on stage now. So first off, we have Meagan Bozeman. She's going to be our moderator. Meagan, you can go ahead and turn your mic and camera on. And then we'll pull up the rest of the panelists.
Okay. Hello, can you hear me?
Yep, we can hear you.
Okay.
All right, so Meagan, unless there's anything else, I'm going to hand it over to you.
Okay, hold on. There we go. It's getting the camera. Wait a minute. Well, it's not going to go with the camera I'm looking for. But anyway, hello, everyone. I am Meagan Bozeman, and I'll start by introducing myself, and then I will have the other panelists introduce themselves. So I am a co-founder of, hold on, let me.
Meagan, did we lose you? Are you still there?
Here, but it's not allowing me to do my camera.
There you go. Yeah. So we got Meagan, Lisa, Christina, and Dawn. You're all up on stage. You just all need to turn your camera and mics on.
Okay.
There you go.
Perfect.
Great.
Sorry about that. Okay.
Dawn and Christina, are you still there? You gotta turn your camera and mics on down at the bottom of the screen. Okay, we got one more to go. Dawn, are you there? Down at the bottom of your screen, there's camera on and mic on. Well, let me reach out to Dawn, and you guys can go ahead and get started in the meantime.
Perfect. Okay. Thanks, Kristen. Okay, so I'll start by introducing myself, then we'll move on to the panelists. So I am co-founder and COO and CFO of Culinary Printworks, which is a company that I co-founded 1 year ago. We are based out of Los Angeles. We are primarily composed of designers and chefs who create beautiful 3D printed food that's delicious as well, and it's really intended to elevate the culinary and beverage experience. So our mission is to make 3D printed food easy, accessible, and scalable. We make it easy by removing the technology barrier and the 3D printing learning curve, because we make the designs and we manufacture the food, and either whether it's our own design or somebody else's vision that we make happen. And we make it accessible through our design services and our e-commerce platform that and affordable, so that people can actually bring this into their home. And that's through our consumer brand, our consumer business called Sugar Lab. And finally, we make it scalable so that our enterprise customers, the restaurants, caterers, and the big brands can scale their products with confidence, while we are the ones who add printers to our fleet and expand our commercial kitchen. So really quickly, I'll share with you what our food products look like, one sample of them. If you go to sugarlab3d.com, you'll see our product line consists of cupcake decorations to drink garnishes to several other applications, including what we call our dessert shells that are perfect for putting mousse in, or I like to put brownie batter or cake in and bake in there. And the shell itself is flavored. This one is pumpkin spice flavored. And then also, please check out our new chocolate line, truffles and bonbons, where we 3D print the shell, and then we add chocolate ganaches in flavors that are just as unique as the shell is on the outside. Just in time for Valentine's, so check it all out at sugarlab3d.com. So with that, I would love to introduce to you our panel members for today. Up here with women who have been pioneers in the additive manufacturing field. They caught the vision about what could be done with 3D printing, and then they were bold enough to actually make it happen. So I'll ask each of them to introduce themselves, their companies, and their products and services. So let's start with Lisa, and then we'll go to Christina, and then hopefully Dawn will join as well, and we'll have her introduce. So Lisa.
Thank you so much, Meagan, and good afternoon and good morning, wherever you may be on this beautiful planet of ours. My name is Lisa Federici, and I'm the CEO and founder of Scansite. We are located in the San Francisco Bay Area, and I actually started my company a whopping 26 years ago, if you can believe that. And talk about growing pains. Boy, I know we're still in the middle of that, but compared to the dinosaur age, there's been a lot of incredible advancements in everything. And we are considered a full service company. So not only do we do 3D printing, and we tend to focus on the very large, the very unusual, unique parts of 3D printing. And we also provide high resolution 3D scanning and reverse engineering. And I've just found over the years that the more sort of complete of a product I can bring to a client, the better off and more successful it will be, as our industry is very fragmented. And also it's an easier sell, quite frankly, for me as a business person. So in terms of 3D printing, you'll see behind me, that is a copy of Neil Armstrong's spacesuits. That is a full-size 3D print that has been painted out. And we made 15 copies of those in conjunction with the Smithsonian's Air and Space Museum's anniversary of the 50th year of the anniversary of the moonwalk. And so those are the kind of prints that we get involved with. Very unusual. So for this is, we're doing a restoration project for a historical restaurant in Napa. And these are, I don't know if you can see them, but these are 3D printed trim parts. And they are made from scanning the adjacent data. So that fell out of the ceiling in an earthquake. And we can create this with very high accuracy and then replace this trim. So what would have cost the historical landmark commission $100,000 if they tried to do this with traditional means, and a plaster craftsman is going to cost them, probably less than a third of that. So those are the kind of projects we bring, to the table, and I'm excited to be here. Really excited and proud of Nora and everyone here that's pulled this off to kind of mainstream and give women their credit due, quite frankly. So yeah, that's what we do.
Thank you, Lisa. Those are amazing props to have in the background. Christina, can you introduce yourself?
Thank you, Meagan. And what an honor to be around real pioneers. I have to say, I have been long enough in the 3D printing industry to know that, or to still remember going to my first conferences in the 20 teens and really only seeing men around me. So this is just a true delight. What an honor. Thank you so very much. So it's interesting because I shared with you, Meagan, when we did a little check-in, that the first time I ever discovered 3D printing was actually when I arrived at my university dorm room, opened up my new laptop, went to read the news, and it was I'd studied in the UK, and the first article that was in the headlines of the BBC News was about 3D printing. And I didn't study engineering, or I didn't study business. I actually studied politics and economics. So I went ahead with my studies already thinking about what the future production would look like and how that would impact our society, our environment. And it genuinely inspired me into imagining, well, could it be possible that this future would enable more local, sustainable, if not even circular models of production, where it's powered by local communities, where it's possible to ship not the biscuit or the cookie, like John Maynard Keynes said, but the recipe. And I've always been quite the tech geek. I'm half Spanish, half Dutch. I've lived all around the world, but I grew up in the 90s in China. So I very much lived the transnationalization of production. I lived how the world's production sites moved over there. I say so because I was lucky enough to be able to go to the markets and be able to buy all the American software, CDs, and I've been testing hardware since 1995. I would test software, so I've always been quite a geeky, tech-savvy person. But seeing the transnationalization of production really made me very concerned about what this would mean to the environment. So when I saw, I was inspired, and I was about to study politics and economics, and obviously I also dabbled in terms of what this would imply in terms of a legal innovation, in terms of even the grassroots, really trying to get a holistic picture of what the future of production and what would this entail. And for me, the role of the entrepreneur is really the problem solver. So going back to the topic of today, I just cannot wait to discuss, well, what do we bring about as entrepreneurs, what challenges we face, and to inspire others to come on board in this venture to realize the products and services of the future that could be more sustainable, more ethical, more desirable. So I started as an entrepreneur since I left university. I was very much interested in working around sustainability and social innovation programs at large, and revving up to the current present. I'm currently co-founder and chief innovation officer at Wikifactory. Wikifactory is a fast-growing SaaS company with a very big vision. On the one hand, we believe in the ingenuity of the next generation of product designers, engineers, and product innovators at large, and we want to connect them with the latest advanced manufacturing technologies, whether it's 3D printing, whether it's robotic arms, CNC, and through what is the latest web technologies, so that they can collaborate together, so we can open up participation in this exciting field that is additive manufacturing and so on. So on the one hand, we have a social platform with a community of over 80,000 designers, engineers working together, sharing either openly as open source their projects so they can really bring the internet to their team, or be able to bring their team on the internet and basically get a virtual co-working space so they have all their design assets, all the documentation, the feedback systems to be able to work together on their designs. And it's been a delight because we have designers working, engineers working on so many different products across product verticals. Because as we know, additive manufacturing has yet to leave an industry untouched. So without further ado, because the community is just can better show you the innovation that they're working on our platform, I thought I'd be able to share a very quick 1-minute video that really captures this energy of these next product innovators that we have going on Wikifactory. Let me connect that in a second. Let me share my screen and hit go. Great. If I find my link. Perfect. Thank you, guys. Share and have a quick little video. Can you see my screen?
Yes.
It didn't seem to be working. Well, I'm going to have to leave it at that and just describe.
Christina, if you would, if you want to send me the video link, it's better to play it through YouTube. Is it on YouTube?
Yeah, sure. Great. Nice idea. I have it handy. Give me a second, person.
Okay, so you need to play it. If you want to send it to me in the chat, I can play it for you.
That's really kind. Thank you. Thank you so much. Apologies. All right, I've got it. Thank you so much, Kristen. Here you go. Shared it. Actually, that's not the correct one. So kind. Thank you. Look forward to the discussion.
Excellent. Thank you, Christina. It looks like Dawn is trying to still join, and she and Kristen will continue to work on that, looks like. But so let's just jump in with our first question, all right? So what I would love to know, and I think that our audience would love to know is, you know, what inspired you to start your company, and what is the genesis of your journey? And I mean, start by saying, when did you start your company, and what really led you and inspired you to do so? So Lisa, would you like to start us out on that?
Sure. So I started my company in 1994, and I was working for another woman-owned company who was a furniture designer, and she used to hand sculpt her products. And it's very difficult to organically design in a CAD package, and we needed to figure out how to manufacture these. And she was also one of the first people to actually create furniture out of composites and graphite and Kevlar and some of the, at the time, Cold War materials. And so we started Scansite. I started Scansite because I had actually heard about 3D scanning. That was around probably a good 20 years prior to 3D printing. And when I first saw my, I saw my first scanner, it was pretty rudimentary and pretty glitchy. And we jumped in with both feet. And, at that time, just to create a 3D file, would take us maybe of a very simple object, probably 6 weeks to get it sort of right. So we kept working on it. I didn't quit my day job, and in order to get her products made, and we did. And then 3D printing came around, and it just seemed like kind of an obvious extension of what we were doing. And we work with, probably every industry out there, with clients like from Tesla to NASA to Boeing to many art and museum, cultural heritage institutions. And so when printing came around, I was all about it. Like, wow, this is great. Although I did have a very big concern about more plastic in the world myself. Like, we're going to need to improve on this. This stuff has to be recyclable. And we created kind of one of the first major, largest 3D print, I believe, still of its kind. And this was when the first 3D printers were SLA printers. And I reached out to a couple of clients on behalf of another Smithsonian project to try to create a 19.5-foot Triceratops skull. And I reached out to an aerospace company, and I also reached out to Hasbro Toys. And they were the only two companies in the US with a 3D printer at the time, and they were both clients. And they jumped on board strictly out of kind of like, wow, this sounds really cool. Let's try it. I don't know if it's possible. So we created that 3D print in, I think it was about 3,500 individual little pieces that we had to glue together. And And then we had to figure out how to get it from Tulsa, where it was ultimately made. We went to the Smithsonian, scanned the Triceratops skull, and then gave that to our aerospace client in Tulsa, Oklahoma, and they created the thing. And then we had to figure out how to get it from there back to DC. And nobody, of course, had a clue how this material would act and if it would stay together and would it twist and would it turn and change shape. And it was too big to fit into a closed truck. And we couldn't very well take it on a flatbed because of weather. So the aerospace company reached out to the Army, and the Army flew it to DC in a tank carrier. So, and this all happened for free, I mind you, because they got so behind this project. And so it arrived at Washington, at Ronald Reagan Airport in the tank carrier. And then they sent a flatbed to the airport to pick it up. And then it got this hero's welcome. They had to stop this, block the streets off and drive this thing to the Smithsonian from the airport. And people were lined up on the street to watch it go down the road. And in the early days of SLA, the material was absolutely breathtaking. It was clear, kind of an amber color. It looked like amber jewelry. It was beautiful, absolutely beautiful. And we used to backlight it and do all kinds of fun things to just make it, even more exciting. And there it sits today in the Smithsonian. So it has held up. Although I will say in the early days, a lot of those materials did twist, they did turn, they did change shape, and they got very brittle over time. So that's one of the big things that have changed about the industry is what I see is not only the software getting better, but the materials continue to get better. They get stronger, the structural integrity of them is better, longer lasting. And but I still would like to see more recyclable material come out. That's a passion of mine.
Great. Thank you. You know what? I think let's welcome Dawn to the panel. Dawn, welcome. I'm glad that things worked out. And
Hi, ladies. Yeah. Well, I was on a Teams meeting, and since I have a Microsoft computer, I think they hijacked my microphone or something. I finally managed to get rid of it. So.
Well, no worries. So we started with intros, and then we were just on to the first question about when did you start your company and what inspired you to do so? And I think maybe if you could go next and combine both of those, introduce us to yourself, your company, and then move into, when did you start everything?
So I first got involved in additive manufacturing, in the early 90s. I was working at Ford, and I came in to work on welding projects there, and I ended up getting involved in a bunch of additive manufacturing related stuff. So I did some work with advanced manufacturing people in the area of actually using SLAs to get better quotes because, they didn't have any 3D, drafting back then like we have now. It's all, you can see it all right on a screen. And so they would make these things out of the SLA and then use them to send out to people to quote, so they would get better quotes. And then I got involved in some additive manufacturing related rapid tooling stuff there, and really learned a lot, had a great experience, had some opportunities to do really cool things working at Ford on additive. And then I was offered the opportunity to have my first company, which was then called Solidica, funded by some venture capital. And so I went off and started it's now the ultrasonic additive manufacturing process. Company called Fabrasonic is doing it now. We called it Solidica when we first started the company because it was solid state metal additive manufacturing, right? Which is cool because if you're a material scientist, you know that really all the problems that you have with metals happen, during solidification and cooling, right? And so, so this is a solid state process. So it took actually a tremendous number of problems out of the way. And we developed a method that worked to put down layers of aluminum. We did a lot of work on really was focused on low volume tooling because you could do that with aluminum. And then we sold product to, Caterpillar and GE and, some really big companies. Worked a lot for the DoD on different kinds of applications and armor and multiple materials. And so that was really fun. The company got rolled up into a joint venture and became Fabrisonic. And I went on to do 2 other companies, one called Akio Energy, which was a no blades electrohydrodynamic wind solution. But what I found out as an entrepreneur is that, you know, knowing something about additive manufacturing and what you can do with it is a huge value, because, you know, we had these weird things we had to, you know, do for our testing and our prototypes. And, you know, lo and behold, we, you know, did additive, right? And it really helped. So the same thing, you know, Perisense, my current company, when somebody has a specialty application, we go off and build a special node and case for the sensor nodes that we use, so that it's actually going to fit on their machine. So even though I'm, you know, not really doing manufacturing now, I've got a lot of experience with it. It's been really valuable to me in several companies. It's exciting technology. So how's that?
That was great. Thank you. And Christina, what inspired you to start your company, and when did you do so?
Great. So I was based in London at the time. I'm now actually in Madrid, but I was based in London at the time in a co-working space for startup entrepreneurs. And in the very same space, through the group, I was part of a tech consultancy. I just learned actually how to code in the 2 years prior. Was a new skill in my entrepreneurial toolkit. And actually I was so, just in terms of that context, I was so overwhelmingly grateful for open source software, both in actually making it possible for me to become a developer in a matter of 6 months and get paid for it. But just how much resources and actual open knowledge was shared. So when in that very same co-working space, we had the chance to support a project called WikiHouse, which was around an open source architectural design. In this case, it was an architectural design system where the design could be converted into flat packed CNC sheets. So we helped them develop a plugin for SketchUp, which would convert the 3D home into flat pack sheets for CNC milling. And therefore you'd be able to have like an IKEA kit of the home. And it was just so beautiful to see that this community that, you know, actually grew internationally from the original open source design shared in London. There were chapters of WikiHouse popping up around the world, really extending the design and remixing the design to local needs. So the house was designed to be more sustainable because, you know, if with 3D design, you can actually envelop things like passive house standards. You can make the house a perfect envelope with precision cutting. And whilst I'm talking about subtractive manufacturing, at the same time, we were seeing other initiatives that were, you know, design communities willingly wanting to share their 3D designs, whether for additive or with or for subtractive, and very much adopting the same kind of sharing behavior of open source software. And at that point, when we were supporting WikiHouse, when they had chapters in New Zealand turning their house earthquake resistant because they'd just been hit by an earthquake in Christchurch, or taking the house design and making it of use for retrofit of the favelas in Rio or in Portugal, seeing how they can parametricize the design so we could use different materials like cork panels instead of plywood sheets. We were seeing also happening in some colleagues in the same co-working space were part of the Enable community that were kind of remixing and improving on the prosthetic hand designs. And it just was an obvious what if. Well, what if we could provide this growing community of designers that are someone doing the process of collaboration in a very different way, very much like open source software, like software engineering. What if we could build this platform, because there wasn't a platform like GitHub. So if open source software and software collaboration at large is made possible online, it's thanks to tools like GitHub, like Bitbucket and the likes, GitLab, there's a few obviously, but there just wasn't a tool for such collaboration around 3D design, around CAD for digital fabrication. And therefore, we didn't stop at houses. We decided to go ahead and build Wikifactory. That took us straight first to China. We found our fourth co-founder in China. He's a Dane, and he was very much involved in the entrepreneurial community there. And as we know, in Shenzhen, we've got kind of the Silicon Valley of hardware. So we went off to China. Obviously, I grew up there, so I had an emotional connection to them, and really trying to get to understand how we could not only build the collaboration infrastructure to handle CAD, collaboration on CAD, but how can we also interface, make sure that our infrastructure could interface with all of these new micro factories and maker spaces and fab labs around the world, really, whether it's larger factories of additive manufacturing, but through down to the downstream maker space, and really interface with this community so that we can genuinely connect the ingenuity of these product innovators with the capacity of smart manufacturing all in one online workspace. That's really the question that we try to tackle. And here we are.
Excellent. Thank you.
Pleasure.
Next question. I'm going to grab one from the Q&A that was very much very similar to my next question anyway. So what has been your biggest challenge as an entrepreneur? And I'm going to add to that. So maybe what was one of your biggest challenges at the beginning, getting kicked off? And what is your biggest challenge now? And since we only have about 13 more minutes, maybe if we can try to just answer in 1 to 2 minutes each. So, who would...
Do you want to go?
Sure. Let's see. So, you know what? I think the hardest part about being an entrepreneur is that when you're just getting going, very often you're doing some pretty simple things, and things go pretty smoothly and easily, and you think you've got this, you've got this covered, right? and then a few problems start to happen, and they take longer than you expect to solve a lot of times, or it takes more money, or so I think there's that sort of moment there when we did all the easy part, and now the hard part is actually like how to scale it up and how to make sure it's really reliable, and this happens, I think, in everything, but so that for me, and that's scary though, when you got a small organization and a lot of problems that you have to try and fix relatively quickly in order to really go to market successfully. So I think that's actually like one of the really hardest things there, is bringing the business model, the technology together at the right time in the right place to meet customer needs.
Yeah, well, I would agree with that, and I would add early on that access to capital is difficult, and it is still a very male-dominated world, and also anytime you go outside of yourself or your friends that maybe are with you or your coworkers along the journey, but you have to do a lot of education to both banks and or investors, and that is a really hard thing, especially if you're kind of doing something that's never been done before, or it's a new way of thinking about an old problem. It's sometimes difficult to convince people that your way might be or is better. So that's definitely a first thing that came up for me, and then scaling as well. So I have had several companies also, and I think that you either need to stay very small or you need to get very large. And if you spend too much time in that middle ground, it'll run you into the ground. It's just really hard to do that very long. So, for us, when we decided to scale, we also went international. So we have international teams in several countries at this stage, and that's been a godsend. And it took me a long time to kind of get that set up. And so then when we're sleeping here, they're working, and when I'm sleeping, we're working, and kind of just being able to do things around the clock has allowed us to be a lot more efficient. And also, I appreciate the different perspectives that my teams overseas bring to the table, and I appreciate the different ages. That I'm 60, so I find working with young people actually really invaluable to my process, because they keep me on my toes, and I've always been an outside of the box thinker, but man, they are a very different world. They grew up than me. So, I love hearing what they have to say.
I echo with you both. It's true that obviously in the early days, the challenges to any startup is numerous and varied. And of course, as you grow and develop in your journey, the challenges just continue to multiply, right? But such is the way for generally tech companies. You just constantly have to iterate and improve. But for sure, this I think being in the digital fabrication, in the additive manufacturing space, indeed, practically, in practical terms, just communicating with this disruptive technology was going to promise in our present and our future. Really, the goal being to bring the world to see you in the horizon was a real challenge, especially because when we started, we were still kind of in the peak of the hype. So to a certain extent, there was either over expectations of what 3D printing was going to do. So everyone thinking, those people thinking that we were going to have 3D printers like we have microwaves in our houses, or the complete opposite of just saying, no, of course, this is not going to be viable. It's too slow. Yeah, you can only print with plastic. I don't want another Yoda head. So indeed, it was finding that middle ground of sense and being able to bring those that you were engaging into the horizon that you wanted to head towards. And it is a delight that, we have much greater awareness. And I think of additive manufacturing now. And if there was anything to say about COVID, I think it has highlighted the utility and actually the effectiveness of 3D printing to deliver supplies on the ground in a local way. I mean, I think it's been 50 million PPE supplies have been delivered by the maker community at large when, Plan A, the government, and Plan B companies weren't able to act quick enough. And this community were so agile and so speedy to really be there for the hospitals, for families, for people who needed supplies today or yesterday. So that definitely was a challenge then. And, in the early days, that might have been the challenge in actually creating this mass community that we wanted to build on Wikifactory. And I feel now our challenge is actually building that community in an authentic way. It's grown to a size. In the beginning, I knew my community directly. I actually reached out to projects that inspired us and said, look, we're building this product for you. You are the next generation of product developers. This saying, I love the saying from software that the future is already here, it's just unevenly distributed. And sometimes I think we thought that our future was more distributed than it actually is. I'm so delighted that it is far better understood, so there's more sense, but I still want to keep it authentic and make sure that we're true to our purpose of opening up participation, of making these technologies more accessible. And I mean it from the point of view of diversity, gender. So this conference is just so amazing in that sense. And we're part of several R&D programs to further this. In the EU, we're part of a program called Critical Making that we want to really assess what is, how platforms like Wikifactory, how this technology can really bring ethnic minorities, women involved, across the world. So really making sure that we can be a bit more accessible, because ultimately this is the promise. If we can make it possible for anyone to be able to start a hardware company or a startup around a physical product design that's digitally fabricated, to make it as easy for them to start a hardware startup as it is to launch a tech startup. I've lived the growth of the startup community. I was part of the entrepreneurial community around tech in London and around the world. And I just I'm seeing it now starting with hardware, and it's just so exciting. And I want to make sure that we can pave the way to really tool and enable that community to realize that they have a real opportunity to develop products that are sustainable, that are ethical, involving of their communities. Because if products had to be to a certain extent transactional, when product supply chains were so expensive, it made sense to have to mass advertise to really push products to people around the world. But now that we can have a conversation, be very close with our customers, now that we can actually reach a niche, and if entrepreneurs are problem solvers, with social technologies, we can arrive at our niche technology, niche markets, and really try to deliver custom products. If 3D printing is making custom complex designs more viable, this becomes extremely exciting to really solve the niche problems, not just the mass problems. And so not for the market of many, but the market of few. And I think doing this in an authentic way that really inspires the next generation is our current challenge. Thank you.
Thank you. I'm going to take the next Q&A question for Dawn or anyone. How did you know when it was time to move on to the next endeavor?
Oh, that's a hard question to answer. In the case of Silica, there was we had two different things going on. We were using our additive manufacturing technology to kind of do two different things, and one of them was really like using additive to create solutions for what was then called telematics, right? And then the other one was to actually build machines. And I wasn't particularly interested in the side of like creating enclosures for telematics and enabling that. But I was interested more in there was the metal side. So it turned out that it was better to split the company, and one company remained doing the telematics with additive solutions, and then the other company was a JV, turned into a JV with another entity, and went on to work on the machines that are now in Fabriconics. So yeah, just the problem I think really was that additive manufacturing can be used for so many things that if you're actually running a company that does it, where in our case was developing the technology, right? What you discover is that you start doing some of this other stuff because people want it, and you're the only one who can supply it. But then it's not enabling you to sort of like build your initial product base, right? So you kind of have to have two businesses. It's hard to do that in one small business. Really hard. It's hard enough to fund one business line, right?
Yeah, well, I can relate to that, and that's exactly why we ended up kind of doing so many different things in so many different industries, is because honestly, when you're trying to survive and you're trying to get this technology off the ground, you are following the money, which is probably the exact opposite of what Christina's talking about there, but that's the way it was. There was nothing such as open source and all of that. And also these are pretty esoteric, difficult things to do. And so even today with the best softwares, and softwares have gotten better. And the big driver, I think, that we haven't mentioned yet is that computing power has radically gotten better. And the power of the internet, which I thought would be the great equalizer in the world, that we all would, be able to access everything through the internet. And that's, somewhat true and somewhat not true. And so, I think when you decide, I personally right now am in a mode of, yes, I'm thinking of what's next, and I would like to be a part of a bigger team. And I think when you start to lose efficiency, or we've got enough going on in different avenues where we provide 3D scanning, we provide reverse engineering, we provide additive manufacturing, which I like to use that terminology versus 3D printing. I think that and I know that Stratasys and 3D Systems and some of the larger hardware and materials manufacturers prefer that term. And that is how I think they want to differentiate themselves from the the small little desktop printer. So we say that because a lot of our prints do go on to, you know, what I would call more commercial applications. And you know, we also do CNC milling. So we do quite a bit of stuff, and we needed to do quite a bit of stuff just to survive. But now we have all of those avenues filled out, and you know, and they're fairly smooth. I mean, and there's not a whole lot of projects that come through the door that could surprise me anymore. But I still love the crazy outside the box, let's see if we can do it kind of thing. And I always take those on because that's what keeps me going. But once you get to that point, you know, it's still a very fragmented industry. It's still, I mean, every single company that's doing what I'm doing is very small. So if we're really going to bust this thing loose worldwide, then it does need to be more accessible and easier to do and better understood. So the prior speaker, she hit the nail on the head with a lot of what I have come up against, especially early in the industry, and I still see it now. There is a lot of misinformation that's out there, and it really does more harm than good, because I spend a lot of my time either trying to lure somebody back into using these industries that has had a bad experience, or they just aren't, you know, they're just not sure. They're not sure how to put all the pieces together. So, you know, I think that once you, like, I've been doing this a long time, and I am ready to see the whole thing fly and go, you know, and go much larger and be part of a bigger team. I mean, that would be a fabulous thing for me, you know. And I think you just need more bodies. At some point, you're going to get to a point where, like, there's only so many hours in a day, and I'm at that point right now. I mean, unfortunately, my kids are grown, and you know, they grew up. Honestly, they were running around companies, they were running around museums, because I don't have a support system here of family. So wherever I was going, they were going with me. The teachers used to say, "Stop taking your kids out of class." I'm going, we're going, you know, we're going to Europe. I got a job to do. But they loved it. And they all grew up just fine. And, you know, I'm ready myself.
So, you know, I have a thought or two about additive manufacturing and how it can be like an economic winner, right? I mean, so one of the problems we have is because it started out as sort of a prototyping method or a small volume method, it's people are still trying to figure out, like you said, Lisa, like, where's the sweet spot for this, right? And so, you know, one of the issues, if you're thinking about it as an engineering or science point of view, is that, you know, it's very, very difficult to have like really exact dimensions in an additively manufactured part, right? And so people do a lot of post, you know, production milling and things like that. And there are applications like the GE, you know, fuel nozzles for their engine and stuff like that have worked out great because they put a ton of time into making it very consistent, and it was an expensive product. But the question is, like, how do you actually create business models for things where you do it additively and maybe it's not quite as accurate, but you could still really achieve an objective. So I think about this, it's a little weird, so bear with me, as you know, human beings had to be invented by nature in order to create flat, square surfaces and extremely accurate dimensions, right? You can't do that in nature. You know, go find something that's perfectly flat, you know, in nature. It doesn't exist, right? So like human beings came along, and after 7,000 or 8,000 years, they really figured out how to finally put a really flat, smooth surface on something on this planet. But, you know, right now there's also a lot of problems we have with dissipating energy, right? Like look at all of our climate change issues and stuff like that. Well, additive manufacturing, you know, can be really, really good at creating geometries that don't have to be perfect. Like trees are all different, right? But they dissipate a tremendous amount of energy, right? And help clean up the environment. So I feel like one of the things that's really important, and I'll stop here, is looking for applications for additive manufacturing where you can make money, dissipate energy, maybe pursue things that are like, you know, working towards reducing climate change and global warming and things like that by having very effective, not so expensive methods of improving energy dissipation in our industrial processes. So there you go.
Thank you. Thank you, everybody, for your contribution on this panel today. It's been fantastic to talk and hear it all myself, and I hope our attendees enjoyed it as well. I encourage everyone to move over to the main floor. I think now is the a networking time. So is that right, Kristen?
Yeah, I was going to walk through kind of what happens next here. But first, thank you guys so much for making it. And Dawn, I'm glad you were able to make it. And it was just a really interesting discussion. So if you're going to be, if you can stick around a bit in the networking session, I'm sure some people will have additional questions. So you can head back to the main stage as well. Before we all do that, I'm going to share what we have coming up next. All right. So,
thank you.
So we are, as I said, we're finishing up the panel right now. And so we're going to have everyone head back to the main stage. But before we do that, I thought I'd give you a bit of an update on what to expect next. So the second block of the day after the break is finance and value-added processes. To start it off, we have Kim Brown. She is from the ASTM International, and she's going to be talking about standards and their impact on the success of additive manufacturing. Up next, after that, we have Stephanie Sharp. I'm really excited about this. I think it really is an interesting topic on the economics of 3D printing through a behavioral finance lens. I think that's really interesting and really fits in well with kind of some of the other conversations we've been having. And then the last single speaker we have is Jennifer Walsh. I'm super excited to have her as well. She's a CFO at Shapeways, and my understanding is she runs pretty much that whole organization, really. So I'm excited to hear what she has to say with regards to their current business expansion. And then we'll end up with the panel on the value of mass customization, which is definitely guaranteed to be interesting. It's run by Twicket, and they're going to come in with a bunch of different, I think, customized parts that have been able to be manufactured using their software from Active Armor, DSM, and Decathlon. So come back and join us in an hour. So it'll be 11:45 a.m. Pacific time and 2:45 p.m. Eastern time. So when I shut this down, you can go on the left-hand side of your screen. Underneath Access Stages, there is the button to return to the main stage for networking. Definitely check out our sponsors. They're all waiting at their tables, and they'd love to speak with you as well. So see you soon.
Thank you.